Greetings, I'm Dev the Developer.
And I'm Glitch.
Today, we're talking about object-oriented programming. It's one of the most important ideas in all of software development, and once it clicks, you are going to start seeing it everywhere. We'll cover what objects actually are, what a class is, and why this way of thinking makes your code so much better than what we've been doing. So let's start with a problem. If you've been following along, we've recently built a user database where a user was just a dictionary with string keys and string values. And it worked. The program ran, but if you look closely at that code, something probably felt a little off.
Yeah, it kind of felt like we were just making stuff up as we went.
Exactly, because we were. Here's what that looked like. Now, at first glance, that looks fine. We have a user with a first name and a last name. But what's stopping anyone from doing this?
Oh, that's bad. That last one crashes because of a capital F.
At runtime, yes. The dictionary has no idea what keys are valid. It does not know that a first name should be a string and not null. It does not know anything about what a user actually is. You are carrying all of that knowledge in your head. And the moment you make a typo or forget a rule, the program blows up when it runs.
Wait, so the dictionary is just a container. It does not actually know it's supposed to be a user.
Right. It has no shape, no rules, and no behavior. It is just a bag. And this is the problem that object-oriented programming solves. The core idea of OOP is that, object-oriented programming, is that instead of storing data in a loose bag, you model your program as a collection of objects. An object has two things: data it holds and behavior it can perform. Think about a dog.
Oh, I love this. You could model anything this way. A dog class for an animal shelter. A human class for cataloging the general population by location and behavior patterns. Or a student class for a school. Just using it as an example.
That is a very specific example for something you're just using as an example. But yes, a dog has things. A name, a breed, an age. Those are its data. And a dog can do things. Bark, sit, fetch. Those are its behaviors. In OOP, we call the data properties or fields, and we call the behaviors methods. An object bundles both together into one.
Okay, so a dog object would have a name property and a breed property and an age property, and then a bark method and a sit method. Is that right?
That is exactly right. And what makes this powerful is that the object knows what it is. It knows what data belongs to it. It knows what it can do. You do not have to keep knowledge in your head anymore. The object carries it for you.
So if someone tries to set the dog's name to null,
the class can prevent that. We will get to that when we talk about access modifiers. For now, the important thing is the mental model. Data and behavior bundled together. Before you can create an object, you need a class. A class is the blueprint. It is the description of what every dog has and what every dog can do. The class itself is not a dog. It is the definition of what a dog looks like in this program.
Wait, so is a class like a cookie cutter?
That's actually a great way to put it. The class is the cutter. Every time you use it, you stamp out an instance, an actual object with real values. You can use that same cutter 100 times and get 100 separate cookies. Changing the frosting on one does not affect the others.
So the class is the pattern and the instances are the actual things. You can have one dog class and make 100 different dog objects from it, and they are all independent.
Exactly. And the technical term for one of those individual objects is an instance. Let's build one glitch. Write out a dog class for me.
On it.
So we start with the class keyword, then the name, then we open the curly braces, and inside we have three properties. Name and breed are strings, and age is an integer. That get set syntax is something we will dig into more when we cover properties properly. For now, just know that it means that a property can be read and written. Go ahead and add a method. Now we have a method. Bark is a void method, which means it does something but doesn't return a value. And look at what it prints. It uses name directly, not a parameter passed in, not a variable from somewhere else. The method has access to the object's own data. That is what makes an object a single unit. The behavior and the data belong together.
Okay, and now to actually make a dog, we use the new keyword.
Right. Let's create two. Two instances, same class, completely different data. Rex is 3 years old and Fluffy is 7. Let's call Bark on each of them.
That's clean. Hey, what happens if I change Rex's age?
Fluffy is still 7. They share the same class, but they are completely independent objects. Changing data on one has zero effect on the other.
Okay, so that is so much better than the dictionary. The class enforces what a dog actually is. You could not just throw a favorite color key in there.
Right. The compiler knows what properties dog has. If you misspell one, it catches it immediately before your program ever runs. That is a very different situation from a crash at 2 in the morning because of a capitalization typo.
That sounds like it has happened to you before, Dev.
C# actually gives you 3 different ways to define a type. There is class, record, and struct. This lesson is about class, and that is going to be the right tool for probably 90% of what you write. But I want you to know that the others exist.
What is a record?
A record is for data that is not meant to change after it's created. And 2 records are considered equal if the data is equal, which is different from how classes behave by default. We will cover it properly later. A struct is for small, simple values, things like a coordinate or a color. It behaves differently in memory than a class does.
So for right now, it's all class.
For right now, it's all class. Once you have a solid feel for how classes work, the other 2 are going to make a lot more sense, because concepts really carry over. Once you start thinking in objects, you're going to look back at every program you have written and see all the things that were secretly waiting to be a class. That instinct is the beginning of thinking like an object-oriented developer. But the only way to build that instinct is to go build something. Don't just watch it. Do it.